Hello and welcome to the Sci-AI podcast. This is episode number 21. Today, my guest is the most celebrated theoretical physicist and cosmologist in the world, Lawrence Krauss. I still have goosebumps. I cannot believe that he agreed to come onto the show. So thank you so much, Lawrence.
Pleasure to be with you virtually.
Thank you. Yes. Lawrence is currently president of the Origins Project Foundation, which celebrates science and culture by connecting scientists, artists, writers, and celebrities with the public through special events, online discussions, and unique travel opportunities. He is the author of many best-selling books on science, and his recent one is A Universe from Nothing. I have read it. It's amazing. You should read it too.
Actually, I actually have a few more books than that since then, but that's okay.
Yeah, yeah. For me, that was the recent one. Yes, but I've also started reading The Greatest Story Ever Told, and started watching some YouTube videos about it. I was just blown with the theories there. So,
and then after that,
thank you so much.
Then after that, you can read the newest one, which is called The Physics of Climate Change.
The Physics of Climate Change. Yes. Yep, absolutely. That's on my list.
Okay.
The next one. Yes. And Lawrence has also appeared in many podcasts, including Robert Kuhn and Joe Rogan's podcast. And I've listened to him like several times already. Please give it a try. You will not be disappointed. I have seen a clip from Joe Rogan's podcast where his mind was completely blown about what Lawrence said about, I think, something related to cosmology. So we'll see, how do we do it today, and our minds will be blown as well. Thank you, Lawrence. Thank you for coming.
Again, pleasure. Look forward to it.
Thank you. Yes. All right. So my first one for you is, what is consciousness and why is it such a difficult problem to solve? Do you think that conscious or intelligent life is rare in the universe? And if you can discuss the odds of that happening in any other part of the world.
Well, look, there's a lot of questions there to unpack, but the first one is I have no idea what consciousness is. I think that's the reason it's so hard, because I don't think there's a good definition of consciousness. First of all, it's not my area of expertise as a physicist, but I certainly read many books about consciousness, and I think we're just at the early infancy. No one really understands. I don't think there's a universally accepted understanding of what consciousness is, and until that's done, at some point, it's hard to know how to discern where it arises. We certainly know many parts of the brain and what they do and what the brain does and how it responds to stimulus. But the self-awareness that we tend to associate with consciousness is an emergent quantity and quality that is currently, in my opinion, not understood at all. Someone once said to me, you can tell how well something's understood by how many books that are written about it. The more books that are written about it, the less it's understood. And if you look at nowadays, you'll see the market flooded with books on consciousness, which says something. As far as consciousness existing elsewhere in the universe, again, it's an open question. There's certainly lots of opportunities for life, potentially. There's probably 100 billion solar systems in our galaxy, some of which may have planets that can house life like our own, or perhaps life not like our own. But certainly the kind of consciousness that humans possess has taken over 4 billion years to evolve on Earth, which requires a fairly quiescent environment. And it's not clear that many places, if we're typical, it's not clear that many places can accommodate that. So I suspect consciousness, if it exists in our galaxy, is quite rare. But there's so many stars that quite rare can still mean there could be millions of conscious civilizations. Unfortunately, the galaxy is a big place, and I suspect it's very difficult. Even if consciousness exists elsewhere, it'll be very difficult to discover it.
Okay, that's great. But if I can add a little bit onto that is, so why do we actually get consciousness? Is it because of language, which I've read somewhere? How did that accident happen?
Well, I wish I had the answer for that. I'd be a well-known neuroscientist, I suppose, or linguistic. One, language obviously plays a role, but it's like chicken and egg. Which came first, language or consciousness? My friend
Right.
Noam Chomsky thinks that language was essential, in a sense. The
Mm.
ability to internally talk to oneself is essential for consciousness. Other people disagree. It's an open question.
Mm. Right. Thank you. Yeah. So let's come to cosmology a little bit, because I'm so intrigued about that topic.
Good. That's something I hopefully know more about.
So what happened in the first 3 minutes after the Big Bang?
A lot happened.
How come
in fact,
scientists...
more things happened in the first 3 minutes of the history of the universe than will happen in the entire future history of the universe, if you think about it. If you count number of events, at least, the event rate, because things were very dense, lots of events were happening very quickly. In the first 3 minutes, not only did the universe cool down to the point where the forces of nature are the ones we observe, the three non-gravitational forces of electromagnetism, the weak force and the strong force. Early on, we think they were all unified in a single force. Particles got mass. Particles didn't have mass before then. Eventually, in the first 3 minutes, even the nuclei of atoms formed. First of all, particles that we know and love, like protons and neutrons, didn't form until the universe was slightly older than a millionth of a second old. But within the first 3 minutes, the light elements of hydrogen, helium, and lithium that are now present in the universe were formed. None of the heavy elements, all the elements heavier than lithium, were formed inside the core of stars. But a tremendous amount happened, so that basically the framework of the universe that we now observe was established within the first 3 minutes. And by the time the universe was, a few minutes old, the temperature of the universe had cooled down to about 1 billion degrees, which may seem warm on terrestrial scales, but it was cool enough that the laws of physics that we can measure in the laboratory tell us how the universe behaved after that.
Wow, that's a great explanation. So did Big Bang, so you must believe that Big Bang really happened.
I don't think belief is a word that I like to use in science. All the evidence tells us the Big Bang really happened, yes, just like the evidence tells us the Earth is round. The Earth is round whether or not you believe it. And the Big Bang happened whether or not you like the idea.
Yeah, I heard on the podcast with Joe Rogan, you talked about the flat earthers and how you debunked all that, and you were so astonished about the fact that people
still somehow cling to that notion. But anyway, I think it was there was a science fiction writer, Philip K. Dick, who once said, "Reality is that which continues to exist even when you stop believing in it," which I think is a really good definition of reality.
Right. That's a great explanation. But can I stay on that topic and ask you, so what is the genesis of Big Bang? Do you believe that it is formed by Christian priests? Yes, who had a PhD from MIT. I mean, somebody like that, you spoke about it, may have formed this hypothesis. So it came from spirituality. So does it mean that Big Bang is actually an idea of Christianity? Because many other religions, like I am a Hindu, they don't talk about Big Bang at all. So what do you think about it?
It's true that the first person to propose a Big Bang happened to be a Jesuit priest, but he was also a physicist, Georges Lemaitre. And when he was writing about the Big Bang, he wasn't writing as a priest, he was writing as a physicist. The fact that he happened to be a priest was something on the side. And as he told the Pope years later, it has nothing to do with religion. It's a scientific theory. You can test it or not test it. So there's nothing Christian about it. There's nothing Islamic about it. There's nothing Jewish about it. It's science. And Georges Lemaitre, as I say, the fact that he happened to be a priest on the side was no more significant than the fact that Albert Einstein, who developed the theory of general relativity, which Lemaitre used to describe the Big Bang, was Jewish origin. I mean, none of that was relevant, and associating those identities with scientific ideas that can be tested. They have to do with testing and measuring the universe, and they have no relationship to religion, race, gender, creed, or color.
That's a great answer. Yes. Thank you. Okay, so I've read somewhere that that you're not a proponent of string theory, and you don't like that at all. What is wrong with string theory? Just like you, my favorite scientist is also Brian Greene and Michio Kaku. What's wrong in what they're preaching and they're researching on?
Well, look, it's not that I'm not a proponent. It's just that I've written a book, my last book, or not my last book, but I wrote an earlier book called Hiding in the Mirror, which is really about string theory. It's just what I'm not a proponent for is making claims about physics theories that aren't true. And string theory is a fascinating idea, but it's not clear that it has anything to do with our universe yet. It may be ultimately a wonderful theory that unifies gravity and the other forces of nature. So the people work on it, and there's lots of fascinating ideas, but the theory is very poorly defined right now, and there's a lot of fascinating mathematics, but yet no real evidence that it has to do with understanding of our universe and our four-dimensional universe. So I have a problem with the hype. I certainly don't have a problem with the ideas on which string theory is based. They're fascinating and they're well motivated.
So about your book, can I ask a question related to it? So how can the universe come from nothing? How does matter gets created from nothing? It's a beautiful thing that you've written there. If you can elaborate.
Well, I wrote a whole book about it. It's hard to condense it quickly,
yes.
But the idea is simply that the distinction between nothing and something is a little old-fashioned, the common distinction, because we know that particles can pop in and out of existence, virtual particles, due to laws of quantum mechanics and relativity. All around us in empty space, virtual particles and their antiparticles are popping in and out of existence and then existing for a very short time and then disappearing. But if particles were to pop out of empty space and have zero total energy, say they were in a gravitational field and the negative gravitational energy equaled the positive energy of their mass, so that they didn't violate energy conservation, those particles that popped into existence could exist, be real and be measured, and so empty space could literally burp particles in existence. Similarly, if space and time are described by quantum mechanics, if we have a quantum theory of gravity, whether it's string theory or something else, then space and time are quantum mechanical variables, and space times can pop in and out of existence, and so a whole universes can pop into existence, and if normally they will disappear very quickly because of the laws of quantum mechanics. But again, if they have zero total energy, a universe could pop into existence and exist for as long as we've been around, 14 billion years or so. And so you can pop whole universes into existence. And if the universe has zero total energy, you may say, where's all the matter come from? But again, gravity can have negative energy. So you can account for you can balance the positive rest energy of particles with the negative attraction of gravity. And you can still have a universe which has zero total energy, even if it's full of matter. And so it doesn't violate any laws of physics to create a universe full of matter from literally nothing. And I find that absolutely fascinating. There's no proof that it happens, but the laws of physics certainly will allow it to happen in principle.
You also talked about the closed universe, the open, and the other one I think was the flat.
And so, that was kind of formalism which was really relevant before we discovered that empty space has energy. But the universe can exist in one of three geometries: open, closed, or flat. These are four-dimensional geometries, and therefore not easy to picture. But it turns out that while we really can't calculate very well in a flat or open universe, we can calculate that in a closed universe, a closed universe must have zero total energy. So if a closed universe pops into existence, it could survive. And if it underwent some processes like we think happened in the early universe, something called inflation, it could expand and survive right until the present day. And in fact, the point is that if you ask what would be the characteristics of a universe that popped into existence from nothing, given the known laws of physics, what would be the characteristics of that universe that you'd measure today? It'd be precisely the characteristics of the universe we see around us. And that's, again, not proof, but it suggests it's possible.
Right, right. So ours is a closed universe or an
Well, it
open
looks
one?
flat on large dimension, on large scales, but the universe can be much larger than we can see. Just like in Kansas, the Earth looks flat, but on larger scales, we know the Earth is round. And so maybe on the scale of our horizon, the visible universe that we can see, the universe appears to be very, very flat. But on much larger scales, it could eventually curve around and have closed geometry. That's what I think is the likeliest bet.
You also talked about that all of the universe's matter can be condensed into 30% in total. And so the rest is the empty space.
Early history of the universe, everything we see, all of the matter and energy that's now in our universe, was condensed in a region smaller than the size of an atom. It's amazing to think about, but
Right.
that appears to be the case. It's fascinating and very difficult to picture.
Absolutely amazing. Right, right. Great. So my next question to you is a little bit of imaginative, sort of my own belief that I wanted to ask you. Why is there such an amazing design and artistry and symmetry in a snowflake? How did nature design it like that? No human, no intelligence did that. So can universe create? Sorry. Yeah.
Of course, the answer is it can, and it does. And there's no design. The universe didn't design snowflakes. You just take the laws of electromagnetism, and you take a polar molecule like water, H2O, which has negative and positive charges distributed, and naturally crystals will form, and those crystals will form remarkable patterns. So something that has the appearance of design, like a snowflake, has no design whatsoever. It's just the laws of electromagnetism combined with the chemistry of water. And that, to me, is a wonderful example of the fact that people should not assume design, intelligent design, when there is none. You let water freeze in the atmosphere and it'll form snowflakes, and those snowflakes look like Christmas ornaments. They look beautiful, but no angels or fairies or little leprechauns are putting those snowflakes together. Just the laws of electromagnetism.
Right. So it's so fascinating that the laws of electromagnetism could create such beautiful symmetries, and that is all has been propagated from the universe itself.
It is one of the many, many remarkable things about nature, which makes it so wonderful to study nature.
Right, right, right. Yes, thank you. So do you think that religion cripples the progress in science and humanity in general? If you listen to the counter argument, then it is a belief of millions of people around the world that God exists, even though nobody has concrete evidence to prove that there is God. So not even evidence like this chair or laptop actually exists right now in front of us. So, I mean, what is your opinion on it?
Well, look, it depends what you're talking about. When you talk about religion, religion means many things to many different people. But on the whole, a belief in fairy tales tends to get in the way of doing progress. And especially when those fairy tales claim certain things are sacred and certain questions can't be asked. So when that happens, when people's ideology, whether it's religion or otherwise, gets in the way of asking questions and opening an open debate, then of course it hinders progress. When people close their minds off to things like the Big Bang because they interpret their religious belief as telling them it didn't happen, of course that hinders scientific progress. And so those kind of religious beliefs can get in the way of scientific progress. Now, other ones are more innocuous, but the fact that many people believe in God does not. Well, first of all, people believe in different gods, right? There are thousands of different gods,
right.
And as many people have said, I'm not the first one to say this, but the difference between an atheist and someone who's devoutly religious is that they just believe in one less God. Someone who's devoutly religious doesn't believe in all the other gods that other people believe in; they just believe in their own. And so, but the fact that lots of religions exist tells us something about the human brain and the way it works, but it doesn't. But once again, it doesn't matter what you believe or don't believe. The universe is the way it is, and turning your back on the ability to openly question and measure and learn from the universe by imposing your beliefs in advance, that always gets in the way of scientific progress.
Right, right. Yes. And you also said in one of your, I think, talks where I was listening to that, universe has no obligation to anything. So you should not have any expectations that universe should have created you like that. You exist and that's it.
Yeah, well, the universe is not
that,
obligated to make you happy, that's for sure. And
right.
Or to be the way you want it to be, and
right.
and you shouldn't. It's an act of incredible solipsism and self-centeredness to assume somehow the universe is obligated to be the way you like it to be.
So, because of the fact that we haven't reached out to the far-flung places of the universe, yes, of course, we had reached out to the far-flung galaxies, but that too are not too far-flung. Something like looking back in time using telescopes and astronomy. So then, is science missing something still? Something that is a phenomenon like a galaxy or dark energy or dark matter. And I'm not even talking about other universes or multiverses. I'm talking about the observable universe, and we still don't know things that are present in it.
Well, of course, we don't know. That's the whole point of looking. If we knew we were missing something, then we wouldn't be missing it. And so that's the reason we have to keep exploring. Of course, there's probably lots of things in the universe we haven't discovered. And that's why we continue to do science. It's the act, again, of a religious person to assume they know everything in advance. Scientists don't. And most of us think we will discover more by continuing to look. And every day we get surprised if we're not surprised. So that's the whole point of science, is that there's a lot more about the universe that remains to be discovered. And it's quite an exciting enterprise to try and discover it.
Right. So, for example, we just talk about galaxies or planets or star systems or nebulas and, several other things. But is there something that, very recently we have found out, something which had not been imagined maybe just 20 years ago?
Well, yeah. I mean, look, dark energy was something 20 years ago 25 years ago, that no one would have thought was there, maybe 28 years ago, because we proposed it 26 years ago, I guess. Right. But 30 years ago, no one would have thought that the universe would be full of energy in empty space, and that would be the dominant energy in the universe. It was a huge surprise, and there will be more surprises. I mean, look how much our picture of the universe has changed in the last 100 years, and I expect it'll be just equally new and excitingly different in 100 years from now.
Great. Thank you for sharing that. So what is your opinion on artificial intelligence and whether we are living in a simulation? Are we living in a simulation? How do we know for certain that we are living in a simulation or that we are not living in a simulation? How do you see the future of humanity evolving in the near and distant future? Well, sorry, it was so many questions.
Yeah, there's a lot of questions there. There's no evidence that we're in a simulation. I don't know why people are so fascinated by this idea, except for movies. There's no evidence that we're in a simulation. And one of the bits of evidence against it, usually in simulations, there are bits that don't work. There are little bits in the screen that might not work. And that would be areas in the real universe where the laws of physics don't apply. We know of no such areas where that happens. But more than that, I don't see the rationale for why we would think we'd be in a simulation, because that would suggest that the individuals who created our universe live in a more complicated situation than us. But then are they a simulation and someone else a simulation? Is it simulations all the way down? It begs the question:
right?
If that civilization that created the simulation that supposedly made us evolved and naturally by laws of physics, then we could do the same. So the bottom line is, I don't see that there's any evidence or any utility in supposing that. Moreover, it doesn't make any difference. As a physicist, we're just trying to find the laws of physics that govern our universe, the universe in which we live, and uncover those. We do, and that's the effort. And so this question of a simulation really has no utility and no power that I can think of, except to provoke people's imaginations about science fiction. It is true that I suspect artificial intelligence, which is already improving all the time, may at some point be self-aware and conscious, and that comes back to your first question. Maybe we'll only learn about consciousness by creating systems that are conscious, that become conscious, and so maybe that's a way to learn about consciousness. But if that's the case, great. We'll have something new to learn from.
Wow. So this is the best one, because I have never, listened to somebody saying like this, that we can learn consciousness from the consciousness that we are trying to put into the artificial machines. Thank you for sharing that.
That'll be the easiest way to learn about it, because you learn by experiment.
Right. Yeah. If we don't bomb ourselves or won't get extinct, then what is your belief? Will we colonize the solar system or galaxy? Or do you think that even with any kind of advancement, due to the nature of space and vastness of it, and the fact that we can't travel to the speed of light or somewhere even near to it today or in near future, will we ever be able to go beyond our solar system?
Well, look, I think, there's no doubt that humans will explore our solar system with things other than machines. We'll explore most of our solar system with machines, but people seem to be fascinated by the moon and Mars. And I suspect in some time in the future, humans will maybe establish a permanent base on the moon and Mars. I don't know if we'll colonize those, but maybe we will. And that's interesting. I think it'll be a long shot to imagine humans going beyond our solar system. In the long term, we'll have to go out into space when our solar system becomes uninhabitable in 5 billion years or so. But that's a long time. And so anyway, I think, we will establish bases on Mars, but people seem to forget that it's just that Mars is not such an easy place to live on, and the Earth would have to become pretty unbearable before Mars became more attractive.
Yep. Yes, that's a great answer. And what do you think that will we be able to build some such machines that can travel?
Well, we'll be able to travel to Mars. To go much beyond, to take humans much beyond Mars will be very, very difficult. And certainly the only way we'll be able to go on long terms beyond Mars is to establish huge ships that have shielding against cosmic rays and that travel slowly and make their way through, just like the Earth is making its way through the galaxy as it goes around the sun. But, I'm not sure that will ever be practical. And if it will be, it'll be very different than the kind of space travel you see in Star Trek or something like that.
Thank you. Yes. So what is your opinion about the multiverse? Do you think that our universe is the only universe, or there are multiverses and ours is just one of them? I'll just take a... Sorry. I'll just add one more thing.
Sorry. Go on. Ask the rest of your question then.
Yeah. So I will just add one more thing to it. Then does it mean that we have different copies in each of those multiverses with different probabilities? Like I'll be a girl in one of the universes while a tiger in another one. So sort of like those kind of probabilities.
You won't be you in any of them. But look, the law, given what we know about the fundamental laws of physics, the best bet is that our universe isn't unique, that there are other causally disconnected universes. And in some of them, the laws of physics may be different as well. In fact, all of them, the laws of physics may be different. And life might not exist in all of them, and all might only exist in some of them. And in those, it is true that if you have there's a big difference between a large number and an infinity. If there's an infinite number of universes, then you're right. There'll be an infinite number of universes that are exactly the same as ours, and some of them with only slight differences. But because infinity is so weird to play with, And so, yeah, if there are an infinite number of universes, there'll be universes in which all the laws of physics are the same, and our Earth, something like our Earth forms, and everything that we see the same happens here, except maybe I say a different word right now. But it won't be the same. It won't be me. It'll be something else. But that's only, those kind of things only are fun to think about, but they're really only relevant if there's an infinite number of universes. If there's a finite number of universes, separate universes in a multiverse, then all bets are off in that sense. It's unlikely. We're certainly unlikely that we have any of those universes will exactly resemble our own, or have. But and as I say, the laws of physics may be different in each of them. But we'll find. Well, maybe we'll find out. We'll find out because we'll understand the fundamental laws of physics. So it tell us if a multiverse is possible. But certainly, our picture of the early history of our universe suggests that the formation of a multiverse is quite plausible.
And I've listened to one of your talks in which you also said that within our universe there are places where there are big bangs about to happen. That was a mind-blowing one, because you said that just like a tiny speck or an atom is about to start a big bang. So can you elaborate that?
Well, look, as I say, there are the laws of physics tell us that on very small scales, the universe is quite exotic, and the laws of quantum mechanics take over, and particles pop in and out of existence, and maybe there are small universes that are being created, but they won't be part of our space. They'll quickly separate from our space and be separate universes. So it's not as if we could see other universes forming, but perhaps they are everywhere.
What is the meaning of life to you? On the cosmic scale, our existence is so minuscule. So then does it even matter if we become so intelligent and populated and we colonize, for a few 100,000 years or something, and ruling this planet and others? So what do you think? I mean, does it make any sense to you? What is the meaning to you?
Well, look, there doesn't have to be any meaning, and we create our own meaning. The universe itself doesn't have to have any meaning or purpose. In fact, no evidence that it does. We humans here create our own meaning in our own life. We decide what's important, what matters to us. We have a finite amount of time to be here on Earth. We try and make the most of it, some of us, and we create our own meaning. But the universe itself, as far as I can see, has no purpose for its existence, and no direction, and in that sense, no meaning. But that doesn't bother me, because I find it remarkable that I'm here at this random time, cognizant with an intelligence that allowed me to understand our universe back to the earliest moments of the Big Bang and maybe to the far future. So a universe with no meaning actually doesn't change my own sense of wonder and excitement about it. Makes my own existence even more special, because I'm so lucky to have popped into existence in this amazing universe.
Right. Great answer. So let me ask you one more question then. So what is it that Lawrence Krauss is so much passionate about, doing in the world today? You have, for so many years, inspired millions of people around the world with your work and with your books and with your speeches and everything. But what is it that you are passionate about doing today in the field of research and science?
Well, look, I mean, I'm fascinated by every new discovery and thinking about what it means. Obviously, there are questions that interest me. What's the nature of dark energy, the nature of dark matter? And I'm
Right.
involved in a large experimental collaboration that's looking at that. I'm also energized by trying to ensure that there's freedom to ask questions and to be able to have open debate. I guess that's what's exciting me more than anything, is the notion of working hard to counter efforts in this country and elsewhere to get in the way of people's ability to openly question. Because the minute we stop that, then science stops. So I suppose I'm become concerned about local human issues. But for me, I just want to keep my eyes open to the universe and yes, try to understand the things that I can understand and make an impact there. But I hope that, as I say, every day I'm surprised if I'm not surprised.
Right. Fantastic. So that's it. I have exhausted all my questions. But Lawrence, thank you so much for giving your time to us. Do you have any parting thoughts?
So just keep asking questions and keep being open to the answers. And thanks very much for the wide-ranging questions. I hope my answers were comprehensible to you and maybe useful to those people who listen to them. But you take care.
Absolutely. Absolutely. They will be, Lawrence. I wish you all the best, and hopefully in the future, whenever you have time, please give us some more time to ask you some more questions around the things that you're doing.
Okay, good. You take care. Thanks a lot.
Thank you. Have a great day.
Okay.
Bye-bye.
Bye-bye. Bye.
Thank you for listening to this podcast. Please support this podcast by liking, commenting, sharing it with your friends, and also subscribing to this channel. Thank you, and we'll see you next time.